So number 2 is the first problem.
Explain why the slope of a secant line.
Mm-hmm.
I'm not sure how much time I want to spend on these ones that require English answers. It's not a very good math problem in my opinion. The slope of the secant line, if I have a function, I'll just explain it to you. There's the secant line, okay? That's also the same as the average rate of change. If I asked you, let's put a grid on here, and I said, figure out the slope of that secant line, you would figure out this value minus that value, that's the rise, and the run would be that. Okay? And so you would take rise over run. So the slope of that secant line is the same as the average rate of change. And it doesn't really matter what your function might look like. In other words, I could have a function like that. And if I put a secant line that goes all the way through like that, then the slope of the function from that point to that point is the slope of that secant line. All right, what next?
Let me see. Number 9.
9 from basic skills. Oh, I see. Now I see number 9. Yeah, here, let me do this. Let me move it up like that. Zoom out a little bit. I help. Create a little writing space. All right. Definition number 1 for, first of all, slope of the line tangent and first derivative mean the same thing. So what they're asking for is the first derivative of this function, x squared minus 5, at that point. Now, I always have mixed emotions here as to how to proceed at this point with a student, because, and this actually tells you, use definition 1. And I'm assuming definition 1 is f prime of x equals the limit of f of x plus h minus f of x all divided by h as h goes to 0. That is your basic, most basic definition of first derivative.
I think that's the way he wants us to find it, not the other like shortcut way you taught me earlier.
Because the shortcut way, you'll never use it again. It's only really needed for one purpose, and that's if you're trying to prove a cusp or a corner. Then the shortcut way is useful. But whenever you're dealing with just finding the derivative, find the derivative function. In other words, find the derivative based on this definition. And when you're doing, this is always one of the hardest parts of calculus, incidentally. Just so you know. Why they teach it this way, I'm not sure. It's not the way I would teach it. If I was teaching you calculus, it would not start here. This is one of the toughest parts, but you got to get through it. Once you get through this part, where you're doing it by this definition, then it gets a lot easier. It really does. Okay? But since we have to do it by this definition, we got to know what f of x plus h is. So if f of x, in our case, it's x squared minus 5. So tell me what f of x plus h is. We need that in that formula.
F of x plus h would be, I don't know.
Okay, the rule you want to use is whatever is in the parentheses, you substitute for x, always. If I said, what's f of 3, you would substitute 3 for x, correct?
Mm-hmm.
You'd get 9 minus 5. Well, we're doing a little more complicated than just the number 3. We're going to substitute x plus h. Okay, so this becomes x plus h squared minus 5. Okay, that's what that is. You with me?
Okay. Yeah.
Now we got to subtract f of x. Well, what's f of x?
X squared minus 5.
In parentheses. Notice that you do need those parentheses, otherwise you'll get the sign wrong on that last number. And it's all over h. Okay? Now, we're wanting the limit of this as h goes to 0. Well, the first thing we have to do is expand that. This is one of the easier ones, by the way. So over here on the left, expand that for me. What is x plus h squared?
Would it be 2x, xh, and h 2h?
Well, it's x squared plus 2xh plus h squared. Still minus 5. Now I'm going to remove these parentheses right here, which becomes minus x squared plus 5. You with me?
Mm-hmm.
You need good algebra skills to do this technique. This definition number 1 is all it is complex algebra. And some of the algebra can get pretty complex. This isn't one of them. This is one of the easier ones. Okay? Now, simplify the numerator. What cancels?
X squared.
What else?
5.
Notice that the only thing that's left has an h in it. And that will always be the case. That's what's left, okay? Now, what can you do with the numerator that would make sense?
Take out h.
Okay, and then cancel that with the bottom. So you end up with, well, let's not skip a step. Here, let's make sure we do this. So that's what we did. I factored out an h, and then I canceled them. And now, what's the limit of that as h goes to 0?
2x.
Exactly. So f prime of x equals 2x. And now it's very easy to evaluate at whatever point they want to give it. So what is f prime at the point 3? In other words, what is f prime of 3, which is the point they give us? There's the 3, the x coordinate. I don't care about the 4, actually, but
Would it just be?
I'm going to in a second, but go ahead. Yeah, it's 6. What's that tell me? That tells me that the slope of the tangent line when x is 3 is 6. Positive 6. Okay? So, now let's go on to the next part of these questions. So we figured out the slope. Okay? And that's key because when you're trying to come up with the equation of the tangent line, what's the most important thing? Slope. Slope. Yeah. Slope. Always slope. Okay? Now, we've got the equation of the tangent line. It's a line. It's linear. It's going to have a linear format. It's going to either be y equals mx plus b format. We could figure that one out. But it turns out that the format that's much more useful in calculus is point-slope format. The reason is you always have a slope and you always have a point. So point-slope format, you remember what it is?
No, I don't actually.
Okay, the way to memorize this, divide both sides by that. What's slope equal to?
I don't. Sorry, I don't follow it.
Divide both sides by what I've underlined. Now, what is m equal to?
Nothing.
Rise over run. In other words, m is going to be this. Y minus y sub 1 all over x minus x sub 1. Well, that's rise, that's run. So if you forget this formula, you can always kind of figure it out based on the fact that slope is, by definition, rise divided by run. Okay? Now, why is this called point-slope format? Well, there's the slope. Whoops, excuse me. There's the slope, there's the x point, and there's the y point. So let's go back and work with problem 9. Tell me what the equation of that tangent line is. Y minus what?
Would it be 4?
Yes. What's the slope again?
2x?
6. It's the slope at that point. Remember, that slope changes. As you travel along that function, that's a quadratic, that's a parabola. The slope changes every time you move right or left. Okay? So it's only a slope of 6 at the point where x is 3. But we know that slope is 6. And what's the rest of it going to be? What's x minus x sub 1?
X minus 3.
And that's actually the answer. In other words, you don't have to put it into y equal mx plus b format. Because you're using point-slope format so much more frequently in calculus, this is considered a final answer. You don't have to distribute it or anything. You could give that answer and you would not lose points.
Mm-hmm.
And it's pretty much that easy. Let's see. Let me think for a second what the best way for me to make some writing space is. That's the reason I says there's no way we're getting through all the problems. Because each one of these is a 15-minute problem.
Mm-hmm.
These are hard. Okay, so let's plot it. Okay, tell me what the graph looks like. And what we're graphing is the function, not the derivative, but the function. The derivative is the slope at any point in the function. How do I plot x squared minus 5?
X squared minus 5.
Mm-hmm. So the third part of that problem says plot the graph of f and the tangent line at that point.
Just having a normal parabola starting at -5
Good.
on the y-axis.
That's where the vertex is going to be at -5. Okay, so that's -5. And it's just a normal looking parabola that opens up like that. And they've said, what is the slope at the point 3, 4? Well, we can tell that when x is 3, the y is 4. So let's call it there. Let's call that point P. And that's the point 3, 4. Okay? And now if I complete the problem and draw the tangent line, well, it's hard to draw a tangent line to a curve that's convex like I drew it. But you get the point, right?
Mm-hmm.
Okay. So that's problem 9. We did all 3 parts. Now, hopefully you'll have to do at least one more like that. What's the next one you're supposed to do?
Here, let me check. The next one is
You can see that the algebra would be a little tougher on 10. In other words, f of x plus h is going to be more complicated, but it's going to come down exactly the same way. On 11, 11 is going to be pretty easy because x plus h is pretty easy.
Mm-hmm.
12 is a constant. Let me plot 12. That's what y equal 5 looks like. What's the slope of that?
Nothing.
0. Not nothing, but 0.
Yeah.
Okay? And so the slope of all constants is 0. In other words, there are always horizontal lines which have 0 slope. Now, I want to do this one if it's not in your assignment, because this one requires a little different algebra. Is that one in?
That one is in my assignment.
Good. I would hope it would be. So let's go back. We're doing the limit as h goes to 0 of, and I don't want to keep writing this. At some point you need to memorize this. Okay, so the way you do these is you start out by listing what f of x plus h is.
Mm-hmm.
What is it for 13?
F of x plus h, it would be 1 over x plus h.
And that's f of x, 1 over x. So now let's start filling in the parts of our equation. So we have 1, I need to write a little bit smaller here. It's a problem. You need a lot of writing space for these. These are always hard algebra. Now this is considerably different, notice. There's no expansion to be done. But what can I do? What can I do with the numerator? How do you add and subtract fractions?
You have to make them equal.
No, you find a common denominator. If I said, what's 1/3 minus 1/4, how do you do that problem? You turn them both into twelfths, right?
Mm-hmm.
Okay, well, that's what we're doing, only we're doing it with algebra or variables instead of numbers. So 1 over x plus h minus 1 over x, got to know how to do this algebra. You're just not going to get very far with these unless you know how to do that algebra. So what's the least common denominator?
X.
It's always the product of the two denominators. Always. Notice that when I had 1/3 minus 1/4, common denominator was 12. 3 times 4. When you have variables, that's always going to be, you just multiply the two denominators, and that's your common denominator. And never distribute these. Always leave them as factors, like this.
Okay.
Now, what goes here in the top left?
I would say x.
Good. In other words, one way to check, and that's one of the reasons I don't multiply the denominator out, is because now I can instantly look at that and see that it's identical to that. And that's what I want. I don't want to change these fractions. I merely want to put them in terms of a common denominator. So what goes in the upper right side?
The upper right side would be x plus h.
Again, parentheses are super important. You will get the wrong answer if you do not use parentheses. And notice that the parentheses aren't there. I got to add them. Okay. So I've got to add parentheses here. Now we got a common denominator, so we can subtract the numerators. What do we get?
We get x minus x plus h.
What's that simplified to?
I don't know.
Remove the parentheses and just operate on the numerator. You got x minus x plus h. The x's cancel, you're only left with minus h. So that is the numerator. This is the denominator. And what you're looking at here is just the numerator. Okay? In other words, we've taken our numerator that had fractions on its own and combined them. That's all we've done. And that's always what you need to do here. Okay? Now what does that become? And remember, this is the long fraction bar here. That one. Right?
I would say h negative h of x in parentheses x plus h.
First of all, how do you divide by a fraction?
You multiply.
By the reciprocal.
Yes.
So what's the reciprocal of the bottom? What's the reciprocal of h?
X parentheses.
What's the reciprocal of h? That h, there's a 1 underneath there. What's the reciprocal of that?
X.
X. Just this. Just the bottom. The reciprocal of just the bottom is 1 over h.
Oh.
Okay? So instead of dividing by h, I'm multiplying by 1 over h. You get it? In other words, we weren't really dividing by a fraction. We had to turn that denominator into a fraction. And now notice what happens. Very good things. The h goes away. And we're left with 1 over x times x plus h. And that's a negative 1, excuse me. The negative sign didn't go away, just the h's. Well, now what's the limit of that as h goes to 0?
It would be 1 over x squared.
Negative 1 over x squared.
Yeah, negative 1 over x squared.
1 over x squared. That's f prime of x. Okay? Now, the rest of it, b and c, are just like before. Once we got to figure out the slope, first of all. So tell me what the slope is at this point, 1 comma minus 7.
Would it just be?
Here's what we're doing. We know what f prime of x is. What's f prime of 1? That's what we're looking for.
Oh, it's just negative 1.
Exactly. So that's the slope at that point of the tangent line. Okay? Now, I'm going to erase everything so we can do... So we know the slope is negative 1 at our point 1 comma minus 7. Now let's figure out the equation of the tangent line. What's the point slope formula, the general formula? Y minus what?
The general formula? Oh, it's just y minus y1.
Okay.
Equals x minus x1.
M.
Oh, yeah.
Slope's always got to be in it. Okay. This is what you need to memorize. I'm going to keep asking until you've got it down by heart. Okay? Now, our slope is -1. Our point is 1 comma minus 7. What's the equation of this tangent line?
So it would be -7.
Hold on.
Minus.
That's the point.
Oh, no. So it would be y minus -7.
Which is y plus 7. Okay.
Oh, yeah. Sorry. Equals. Wait. Let me think this through. Just -1.
Okay.
In parentheses, x minus 1.
Perfect. There is the equation of that tangent line. And you're always going to be using point slope every time you do this. You're never going to use slope intercept format. Okay? Now, let's dispense with the, well, we don't need to dispense with the graph, I guess. I can graph that easy enough. That's a hyperbola, right? That's your most fundamental hyperbola. And what they've asked you, I apologize. I've made a big mistake here. I was using the point from number 10 on this problem, and I should have been using that point. Okay? So let's go back. Got to get this right. Our slope was, or here, let me start at the top here. F prime of x equals -1 over x squared. That's the derivative function. And our point is at -1 comma -1. So it's still -1. Okay? Despite the fact that I used the wrong point, because it's squared, 1 is the same as -1. So our slope is still -1, okay? And now if we do point slope format, we get y plus 1 equals minus x plus 1. You with me?
Mm-hmm.
Okay. Now, my mistake was not revealed to me until I tried to graph it, because I know what that graph looks like. And notice that there is no point at 1 comma -7. So I was immediately taken aback. But there is a point at -1 -1 right there. With the slope of that tangent line, -1. And the equation of that tangent line is that. Okay? But using this definition to solve for it was harder. It was much harder algebra than the first one we did. Okay? Do you know the power rule yet? I taught it to you last time.
Yeah, you did. I do know that.
Well, let's talk about it, because it's a great way for you to check your answer. Okay? In other words, they don't want you to use the power rule to solve this problem, but here's how easy it is. Here's the function. Right? That's 1 over x. Apply the power rule. What's f prime of x?
For which one?
13.
It would be...
I wrote it differently. You've got to write it with x in the numerator. But there's a power, it's just -1. So now use the power rule. Start with the exponent, -1.
So just be -1, x, -2, infinite, and...
That's it. That's minus x to the -2, which is minus 1 over x squared. In other words, what took us 15 minutes to do by the hard way, using the power rule, took us about 15 seconds.
Mm-hmm.
And this is the only way you will do it once you get past this section. So just bear with this section. Derivative calculus is going to get a lot easier. But at least when you come up with an answer for your derivative function, you know what the answer is if you know the power rule. The answer better be minus x, or minus 1 over x squared, or minus x to the minus 2, same thing.
Okay.
Okay. Now, 14 is going to be harder still, algebra. Notice that we're going to have to do x plus h squared, so we're going to have to square that out and then combine it with another fraction that's 4 over x squared, and it's going to kind of be a combination of number 9 and 13. What's next on your list?
Next on my list is 19.
Okay, which I assume is a different page also. Yeah. Okay. I may not have to. Yeah, actually, it does matter if I. Oh, shoot. Sorry.
Cool.
I closed out my window that had your. I gotta load Gmail again.
No worries, man.
And then I'm going to have to go down because that's a file that's been seen already. Okay. Let's do this, and we'll download that first. And then if I open it up, I think I get a little clearer image. Yeah, I do, actually. 19?
Yes.
Okay. You're going to have to go to page 139 and tell me what their second definition is. Or I'll tell you what I think it is.
What do you think it is?
Oops, hold on a second. I got to write on this thing. The other definition for first derivative is f prime of c. In other words, the slope at point C is f of x minus f of c all over x minus c as x goes to c. Is that it?
Yeah.
Exactly?
Yeah, it is.
Okay. I kind of don't like this definition. And the reason is it's only going to work at a specific point, C. It's not going to be robust. In other words, the first definition, you could figure out the slope at any value of x, right? In other words, you've got a derivative function where you can just plug in x, and whatever x you plug in, you get a different slope. Whereas this definition only gives you the slope at point C. So this one's not nearly as powerful. Okay, but useful in some contexts. When you're trying to prove cusps and corners, this is the one you need to use. So they force you to go through it. I don't like doing it because I used to assume that you could always get the answer from doing it by definition 1. But let's go through this one. So,
Wait, can I go use the restroom real quick?
What's that?
Can I go use the restroom real quick?
Sure.
Sorry about that.
So again, we look at our formula or our function, and we need to know f of x. We need to know f of c. What's f of x? I've written it over here on the right. It's x squared minus 4.
Mm-hmm.
What's c?
I have no idea.
It's the x coordinate.
X coordinate. So that would be
at point P.
Wait, no. That would be 2.
Okay, so f of 2. What's f of 2 equal to?
0.
Okay. So f of c is 0. So here's what we have in the numerator. We have x squared minus 4 minus 0 all over x minus 2. You with me?
Yeah.
Okay. Well, I don't need that. And I want the limit of this as x goes to c, which is 2. Well, so now we have to solve that problem right there. And that will give me my slope at that point, 2, 0.
Okay.
Now, notice that if I just substitute 2 in, I get 0 over 0, so we can't do that. So this is the limit problem that you worked on all last week. How do you solve this?
I would factor the top, and I'd go x plus 2, x minus 2, and then cancel out the x minus 2, and then plug in 2.
Exactly. So what's the slope?
4.
That's how you do it. Now, determine an equation of that tangent line. What's the equation of the tangent line? What's that?
How would I determine an equation from that?
Well, we know slope. That's a good starting spot. And we know a point. So if you know slope and you know point, use the point slope format for a linear equation. We did it on the 2 previous problems.
Okay, so it would be this.
Give me the general. Give me the general until you have it memorized absolutely.
Y1 minus y.
No, it's y minus y1.
Y minus y1 equals m in parentheses x minus x1.
Okay, now fill it in.
So
2, 0.
okay, so y minus 0 equals 4 in parentheses x minus 2.
There you go. That's the equation of that tangent line. Now we don't need the 0, so it's y equal 4 times x minus 2. And that's all they wanted here, was for you to find the slope and the equation at that point. Notice again how much easier it would be if I could use the power rule. Use the power rule on that. What's the derivative?
Subtract.
Okay. And now evaluate what is the slope when x is 2?
4.
10 seconds. It's astonishing that they insist upon torturing calculus students by making them go through this hard method first. There's just really no point to it. Is all it does is discourages people and hurts their morale because these are so hard. It's not the format that's hard, it's the algebra. When you have 1 over x plus h and you're combining that with 1 over x, that's difficult algebra. I mean, but that's all it is difficult algebra. Okay. So, what's the next one on your list?
It is.
Be worth doing another one of these also. I said I hope it's less than 26. Although, not really. Not really, because, hold on, let me let this dog
Okay.
in here. dog does not like to be kept out of the tutoring sessions. Come on in, Sonny. All right. What's next? After 9?
The next one is 33.
Okay. If they're only going to have you do one of those, that's fine with me. I don't like those anyway. Whoops. All right, let's look. For the following functions and values, find f prime at a. Okay. Doesn't ask you how to do it. If we're going to get through all of these, we need to do it the easy way. Did you say 33?
Mm-hmm. Yeah.
Can't even show you how to do that the easy way, because there's 5 rules in differential calculus. There's the power rule, there's the product rule, the quotient rule, and the chain rule. And to do this 33 the easy way, you'd have to write it like this. Hold on. In other words, here's our function. But radical signs don't do you any good in calculus. You always want to turn radical signs into fractional exponents. So f of x is really this. It's 2x plus 1 to the 1/2 power, right? Now use the power rule on that. What's f prime of x?
Negative 1/2.
Not negative. Where are you getting the negative? Start with the exponent.
Yeah, you subtract that with 1.
You don't subtract it yet. That, in other words, that's your coefficient.
Oh, yeah.
That's what you start with. And then you take everything else, and then you subtract 1 from that previous exponent. What do you get?
Negative 1/2.
Okay. And now, I won't bother explaining it to you yet, but you have to apply the chain rule. So I got to multiply that by the derivative of what's in the parentheses. And the derivative of what's in the parentheses is 2. Okay? So that 2 cancels with that 2, and we're left with f prime of x is 1 over the square root of 2x plus 1. You see how I get that?
Yeah.
That's what 2x plus 1 to the negative 1/2 is. It's 1 over the square root of 2x plus 1. You need to get really comfortable going back and forth between radical signs and exponents and negative exponents, what that means. You can't use the power rule if your variable is in the denominator. You got to force it into the numerator and use a negative exponent if that's what you have to do. Okay. Now, what's f prime of 4 equal to?
Three 1/3.
Good. The power of the power rule. We'd still be working on this problem if we had to do it by either of the other 2 definitions. Now, I don't mind doing that hard algebra, and it's definitely something you need to do. You haven't been tested on this yet, right?
Mm-hmm.
So you got to be able to solve these always by definition number 1. Definition number 2 is actually harder to do in my mind, and it's not as robust. So I never use definition number 2. I always have used definition number 1, found the derivative function, and then you can evaluate. In other words, I can evaluate this f prime of x at any x I want to plug in. It's not, if I use the second definition, I would be forced to use the point 4. And I would have to, and they don't tell me what to use here. It just says find the value of f prime of a. So I'm going to do it the easy way, which we did. It's the equation of that tangent line. A little tricky. What's the general equation of a line?
What?
It's the general equation of a line in point slope format.
Is it just, oh, it's y1 over y. No, y1 minus y.
No, it's y minus y1.
Y minus y1 equals m paren x1. No, just normal x minus x1.
They're always in the same direction. Okay. Now, the point we have is a equals 4. Well, what's y? 1. If x is 4, what's y1? I need to figure out what y1 is. Go to the original function.
Mm-hmm.
What's y1? In other words, what's the full point? What are both coordinates of the point? We need both of them because we need an x sub 1 and we need a y sub 1.
It would be 1/3.
No, it's 3. You're not plugging it into this derivative function.
Oh, you're just okay.
Into the original function.
Okay.
In other words, the original function has an x value of 4. Okay? So if I want what the y value is there, our point is 4, 3. That's the point where we're finding the equation of the line tangent to that point. Okay, so that's my point, and that's my slope. What's the equation of the line?
So it'd be y minus 3 equals 1/3 x minus 4.
You got it. That's the way you do it. What's next?
We have 38.
Okay. Lines tangent to parabolas. Let's see, what did those instructions say? Find the derivative function, find the equation of the line tangent at the point a comma f of a, and graph. In other words, these instructions are identical to number 9, 13, right?
Okay.
Only they don't tell us how to find the derivative. So we're going to cheat a little bit here. In other words, if we keep doing these the hard way, we're not going to get very far very fast. You know what I'm saying?
Mm-hmm.
So let's do it the easy way. And then, I don't know. You're going to have to figure out how to do it the hard way at some point. Which number are we doing? 39, 38?
We're doing 38.
38. Okay. This is pretty easy to actually do the hard way. So let's do it the hard way, just to give you a little practice at that. And we're always going to do it I'm going to always use definition number 1. It doesn't tell us to do otherwise. So let's use definition number 1. In other words, we've got f prime of x is what? What's definition number 1?
Limit h is approaching 0. F of x plus h minus f of x all over h.
Okay, good. And now we need to know f of x plus h. What's that? And we need to know f of x. We know f of x. What's f of x?
3x squared.
3x squared. I covered it up. That's what it is?
Yeah.
Okay. So what's f of x plus h?
3, and then in quotes, x plus h squared. In parentheses.
Expand that. You do have to always expand that if x is in the numerator. If it's in the denominator, then you're going to have two fractions. Because remember what we're doing here is we're taking this minus this. That's what we do in that definition number 1. Is we take our top function minus this other function. So expand this. 3 times what? What's x plus h squared?
What?
What's x plus h squared? That's what I mean by expanding it.
Oh, it would be x squared plus 2xh plus h squared. I mean, yeah.
Okay, now distribute the 3. So we have over here 3x squared plus 6xh plus 3h squared. Plus 3h squared. Okay? And we are subtracting from that. What's f of x?
It would be, so we're just subtracting 3x squared, so it would cancel just the 3x squared.
Exactly. And the key thing to remember here is that when you cancel everything, you're only left with terms that do not, or that all have an h in them. Notice. Right? In other words, everything else got canceled. If there was a number 5 over here, there'd be a minus 5. In other words, you're never left with anything in your numerator that doesn't have an h in it. And that's vital, because here's what I'm doing. I'm solving for the limit of that as h goes to 0. Well, so what am I going to do? Notice that that's 0 divided by 0 if I do direct substitution.
So I can take out h, though.
You factor out an h.
So it would just take me to 6x plus 3h. And then as h approaches 0, it's 6.
Well, no, those cancel. Now what's the limit of that as h approaches? 6x, exactly. And that's what we knew it was all along, right? The power rule, that becomes 6x instantly. I just wanted to give you a little bit more practice with doing it the harder way.
Okay.
Okay. Now, our point was a equals 2. So what's the slope of my equation of my tangent line?
Is it just 12?
Okay, so I'm going to erase all of this. We know slope is 12. What's the point? In other words, the only point we have at this point is the x value, or what they call the a value. What's the y coordinate at that point?
0.
Oh, excuse me. Hold on a second. I screwed up again. All right. We're on this one here, aren't we? Okay. So our point is 0, 0. What's the equation of the tangent line?
So it would be y minus 0 equals 12x.
That's the equation of the tangent line. That's it. Okay. All
right.
Now, they did want you to graph that. And this was a fairly straightforward parabola, a little skinnier than most because it's got that vertical stretch factor of 3. And I want the slope right there, right?
All right.
Hold on a second. Our slope was 0. know how I got so off here. No, I think I was jumping around problems. Here's what's f prime of x again for number 38?
F prime of x for 38 is just 6x.
6x, right?
Yeah.
Okay, what's f prime of 0? That's the slope.
Oh, it's just 0.
Okay, it's not 12.
Okay.
I think we both substituted 2, which is 39. But the slope is 0, so the equation of the tangent line is y equals, the slope is 0. So it's just x minus 0. Which is y equals x squared. No. Okay. I made a mistake here because I got mixed up between these two problems, but we don't have to go all the way back to the beginning. Because all we have to know is these two things over here on the left. We need to know what the derivative function is, which is 6x. In other words, wherever I go on this parabola, that'll tell me what the slope is. If I want to know the slope right here at this point, where say x is 4, that slope is 24. If I want to know the point at where x is 0, that's a horizontal line. In other words, the equation of that is that. Okay, what's the equation of that horizontal line? That's the equation of our tangent line.
Just x equals 0.
Don't make, that's a real common mistake to make. That is
I
exactly.
just got it because it's running through the origin, y equals 0.
Exactly. In other words, all horizontal lines are y equals something. All vertical lines are x equals something. So if I say, what's the equation of the x-axis? It's y equals 0. If I say, what's the equation of the y-axis? It's actually x equals 0. Okay? So be careful of that one. I'm glad we did that problem. Okay, and we graphed it. We drew the tangent line on to the next one.
Wait.
We did 38. What's next?
Oh,
In other words, we did all 38. 38 wanted the slope, wanted the equation of the tangent line, and wanted us to graph it. We did all of those.
41.
Okay. Use the definition of derivative to determine the derivative of ax squared plus bx plus c. All right, let's start by doing it the easy way. What's the easy way? If that is our function, what's the derivative of it?
It would be 2ax plus b. That's it.
That's it, exactly. Okay, so we know that's the answer. Now let's see if we can do it the hard way. We're going to use technique number 1. So let's start by listing, instead of f of x plus h, it's probably better to list f of x. We're going to need that also. And this is what f of x is. Now tell me what f of x plus h is.
It would be a, in then parentheses, x plus h parentheses squared plus b parentheses x plus h squared plus c.
Not squared.
No, yeah, sorry, I don't know why I said that.
Okay. So those are my f of x plus h and f of x. Now let's use the limit definition to figure out f prime of x equals the limit of what?
0. X is approaching 0.
As h, not x, but h.
H is 0.
There's a difference. There's a big difference. But okay, and so we got to expand this, right? So what's x plus h squared?
So it'd be a and then x squared plus 2xh plus h squared.
Plus bx plus bh.
Yes, plus c.
Okay, plus c. Now, that's our f of x plus h. And I'm going to go ahead and write the numerator fully. Ax squared plus 2axh plus you with me?
Yep.
Plus bx plus bh plus c. That's f of x plus h. And then I'm going to subtract from that f of x, which is our top function. Ax squared plus bx plus c. Again, the parentheses are absolutely vital. If I leave them off, I'm going to get the sign wrong on those last two terms. Now remove the parentheses, simplify, and combine. And remember what I said, every term that does not have an h in it should disappear. Well, this first one doesn't. That's going to cancel with that. This bx doesn't. That's going to cancel with that. And the c doesn't. That's going to cancel with that. So now what I have left in the numerator is 2axh plus ah plus bh all over h. Now, instead of factoring out the h, let's just cancel it. I can cancel that one, and that one with that one, right?
Yeah.
And now I have 2ax plus a plus b. Now, one of these was squared. This is ah squared. So there's still an h with that. In other words, this is squared. When I expanded it out, notice that it's h squared right there. Oh, you can't see where I'm pointing. That's h squared. So when I multiplied it by the a, I should have had ah squared, and I left off the square.
Okay.
And then when I factor out the h, it doesn't get rid of all of them. It still leaves an h with the a term.
Okay.
Now, as h goes to 0, this whole thing goes to what? In other words, that's what we get. Now let h go to 0. What do we have?
2ax plus b.
And that was our derivative. 2ax plus b, using the power rule. We just did it the hard way. That's all. Okay? And let's see if there's anything else there we missed on that problem. Okay, where a, b, and c are constants, we use the definition to determine what the derivative was. This notation that you see here, that's the same as f prime of x. It's just a little more descriptive. It tells you that we're taking the derivative of the function with respect to x. Okay, b is pretty easy. Hold on. The answer to a, in other words, the derivative, this a is not the same as the a's here. Let's say 41a was the derivative function was 2ax plus b. And now notice that they've given us a quadratic that merely has a different a, b, and c. Well, in this part here, what's a and what's b?
It would be 8x
Hold on.
minus
What's
3.
a? Don't look at the derivative function. Look at the original function.
A
Is 4.
equals 4.
What's b?
B equals 3.
Negative 3.
Negative 3.
There's that negative 3 right there. Okay. Well, if our derivative is 2ax plus b, what's the f prime of x?
8x minus 3.
Good. And notice that if we did that problem the easy way, using the power rule, it's 8x minus 3. Now find f prime of 1.
5.
Good. What's next?
Basically, it's all just reiterating that, so I really don't feel like I need any more. Like, you helped me out a lot.
Okay. Is this the last page, or is this, we still got another page to look at?
Yeah.
Here,
There's 53. You want to look at that?
Let me see what's on this other page.
Yeah, the 53 is really easy.
Yeah, you're right. It is. Here, tell me.
Let's
Let's just go through 53 real quick. At which points is the slope of the curve negative?
C and D.
Which points is it positive?
A, B, and E.
List the slopes in decreasing order based on steepness.
A.
Hold on, just a second. Okay, we can do it without writing. A is the steepest. What's the next steepest?
C.
I would actually say B.
Oh, okay, yeah, that makes
In
sense.
other words, if I draw a tangent line here, the slope of that, first of all, that's negative.
Mm-hmm.
So if I'm putting them in order, I got to go from positive, most positive to next positive. So it's A,
B, E, and then DC.
very good. Very good. Okay. Is that the only thing on this page?
Yeah.
Okay. Well, you sure you don't want to? Was there another question on the previous page that we could look at?
No, you helped me out a lot. Thank you.
Cool. Very cool. This, keep in mind, it isn't going to get any tougher than this for a while. For the next month, it'll be easier. You'll be using the power rule only. They're never going to make you go back and do it this hard way again.
Okay.
But you're going to have to learn the product rule and the quotient rule and the chain rule. So it's not that it's not hard. It's just not as hard as this limit definition quotient.
Okay. Cool.
All right. Jake, have a good, let's see. We got another session tomorrow at 3.
Oh, okay. Okay, cool. Well, I'll see you later.
Okay. Talk to you tomorrow. Bye-bye.
Peace.